Before I start this, in another part of my life, I'm also serving on the executive board for the MIDI Association. Been involved for a bunch of years on our work with MIDI 2.0. None of that content is in this talk, but at the ADC, Franz Dieter will be doing a talk sometime tomorrow or Wednesday on a MIDI 2.0 library he's developed at Native Instruments. We're gonna have a table upstairs. Please come check it out, talk to us, learn about why you should be excited about MIDI 2.0, what you can start doing now to have your hardware and software ready for deploying, because all the operating systems support it now. So let's get the rest of the universe working with it. Thanks. Why I'm here today, though, is to talk about value trees, which again, no math in this talk, no calculus, no trig, no algebra, just JUCE. Another title for this talk was Confessions of a Value Tree Skeptic. I've been working with JUCE professionally for between 10 and 15 years now. Love it. The one part that never clicked for me that's used throughout the framework is the idea of a value tree. And it just seemed unnecessary to me. At ADC 18, David Rowland did an incredible talk that was the best, most compelling description of why you would want to use it, but it didn't work for me yet. 4 years ago, I started working in the job I have now, moving into a team that was heavily using them in the app we use as a companion app to my company's instruments. I could not avoid it anymore. So over the last few years, this is about how I came to terms with that, what I did to convert from being an enemy to an advocate, and see if there are lessons we can draw from that maybe. If you've never worked with a quick crash course on what they are. If you go on the JUCE website, it'll tell you the value tree is JUCE's secret weapon. Maybe, maybe not, but what it is a super, super flexible data structure that at its heart holds a set of key value pairs. And the values can be basically any data type, as long as it can be converted to a JUCE var type. There's no fixed schema for data, which makes it obviously totally flexible. Anything can be added, removed at runtime, at the cost of you maybe not knowing what's going to be there. The value tree, every value tree has a type, which is a class called a JUCE identifier. And in addition to the key value pairs that it can have any number of, it can also contain within it 0 or more child value tree objects, which is the tree part. Application code can listen to anything changing in the tree. So one thing that does is that properties change as you add and remove child trees. You have a centralized place in your app where its entire state is visible to you and can broadcast to any part of the app completely decoupled from every other part. And in addition, part free with that comes the ability to add undo and redo operations. So there's a lot of utility in there. Internally, what it is there's, if you see here, down below, there is a shared object, which is created automatically when you create a new value tree. All of the data is actually stored in there, and copying and moving value trees around just increments reference count on that shared object. So moving these things around is super cheap, even though it's containing the entire app state. So in basic usage, please give your variables better names than the ones I used here. So you have some identifiers. Everything is identified by key, obviously. So we have a root identifier for the structure that we're working with, a leaf child type that we'll add later, and some property names. Create a value tree just by declaring it with the type, and then you can add properties with this bunch of API text. One of the things I did not like about value trees was that working with them always feels like you're calling functions. You're using an API. It's very noisy to my taste. And I know an opinionated programmer is rare, so this is what they look like. And to retrieve values from it, it's the same kind of thing where you're taking the object, calling an API function on it to get that property name and get its value back, append a child to the tree with another function call. What that looks like if you convert it to XML, value trees are structurally almost identical to XML unless they're almost identical to XML. So what we did in the previous two slides looks like that. Or if you wanted to think of it in C++, like this, except there's no type data really attached to the values. As I butted my head against this for a few years, I wanted to build a layer that I could put on top of these to make them something that I was more happy to work with. And in all of my work, I have basically these three theses that I approach problems with. The best way to understand something is to use it in earnest. When I had kids, one of the things they told us was that your baby will learn about the world by putting things in their mouth. I learn about the world by writing code about it. The best way to critique something is to make something like it that you like better, not just software. When I hear a piece of music that I don't like, that just drives me to write a piece of music that I do like. I'll be writing music until I'm 400 years old because of that. And all problems in computer science, except for one, are solved by adding one more layer of abstraction. So the broad goals for the system that I wanted to build was, again, taking that kind of noisy code using the ValueTree API with function calls on the in and out. I wanted it to look like plain old C++ code. I wanted to be able to have an object that I could declare and access attributes to it just with dots or arrows and variable names. So it looks like a plain old data struct. So then the question became, how do I do that? And I took a couple of models in the path between where I was then and where I am now. The first one of those models is the idea that you see very common in web development called an object relational mappers. They've been in use for a long time. I first became aware of them, Ruby on Rails, when that was big 15, 20 years ago. There's a class out there on that called Active Record. In Python, they have SQL Object and SQL Alchemy. Java has one, Core Data. .NET has their own. What that does is a bridge between syntax that looks like programming, regular programming, and some other API. It's an abstraction. It's sometimes a leaky abstraction that can cause problems for you, but on a day-to-day basis, it makes your path of developing much more smooth because you feel like you're just writing code. Simple code, not API code. Another model that I took for this, and in the Python world, there's a project called Requests, which takes, its tagline is HTTP for humans, which is solving exactly the same kind of problem that I was having with this, where Python ships with a library called URLlib3, but it's very noisy to interact with it. Kenneth Reitz, who is the developer who developed Requests, put this layer on top of it that abstracts it in a very clean way so that you didn't have to worry about a lot of the corner cases. They were handled for you in intelligent ways. And if you needed to override that, there was a very simple way to do that. It imposes some structure on what's essentially a structureless bunch of tools you can throw at a problem. Specific goals where I wanted to be able to hide the property access between dot and arrow syntax. I did not want to make it feel like I was calling functions. I wanted to make it feel like accessing attributes. One of the other things, as we said before, because anything that can be stored in a JUCE var can be stuck inside of a value tree, there's no type safety. Most of the time when I'm writing code, I a priori know what the type of any one of my attributes is. I wanted a way to have that enforced. I wanted to have a way to have that expressed in the source code that was obvious to the people that were using it. Again, because value trees are completely dynamic, it's possible to encounter one that doesn't have an attribute in it that you think should be there. And by the same token, it's possible for it to have attributes you don't know are there. Wanted to be able to reduce and remove the boilerplate. There's a lot of, and when I started working at Artifon, one of the previous developers who wrote most of the app had developed a class he called ValueTree Wrapper, which I'm gonna be honest, I stole a lot of these ideas and put my spin on them, but I'll give him credit in a minute. But even using that, there was a lot of repetitive boilerplate code that I did not want to have to put myself or anybody else through. In order to respond to changes in a value tree, you have to declare a class that's a subclass of value tree listener and handle the callbacks from that way. And we ended up having function source files that were hundreds and hundreds of lines long of switch statements that are not really easy to reason about. It's very easy to be confused by why code isn't being handled because you'd already handled it elsewhere. I didn't want that to happen. And enabled something that I'm gonna call functional reactive programming. If you look online, what I do is not exactly what the rest of the world calls that, but it's close enough. Again, decouple all the things, and we'll talk about in a little bit how that's been beneficial, downstream. Value trees are not thread safe. The application that I spend most of my time working on is a large number of threads. I wanted to be able to safely synchronize everything there with as little effort as possible. And actually, it ended up being pretty wonderful how well that works. Programmers should not need to know that they're using value trees underneath of the hood, unless you really want to. If you want to go reach underneath and use the raw API, it's a completely transparent layer on top of it. So that being said, quick bunch of acknowledgements. This is the crew at Artifon. Chris Roberts, CPR 2323 on the JUCE forum. Hey, Chris. Wrote the original value tree wrapper that we used at Artifon. The rest of my team has all made contributions in one way or another to it. Again, David Rowland's talk at ADC 17, if you haven't seen it, I recommend it highly. And Matt Gonzalez, who spoke earlier this morning, tried to convince me 5 or 6 years ago that I should be using these. I ignored him, and I should not have. So what I did come up with is a new set of class, a library frameworky kind of thing that I call Cello or Cello. Cello for cellophane because it's the universal wrapper, and Cello because I like having something where the argument over how to pronounce it, I'm tired of youngsters saying GIF when it's really GIF. So both Cello and Cello are correct pronunciations. Anybody arguing about it, I will revoke your license to use this. Which currently consists of these 5 classes. Cello object is the thing that relates to a value tree itself. Cello value, which is an individual attribute of it. Query, which lets you build a bunch of basically database-y type things on top of a value tree, which ends up being really useful. The sync class, which is a way to keep threads using value trees under the hood safely. And there's an IPC client, which lets you do the same thing between processes in just a few lines of code. Okay, so Cello value, I'm gonna do a little bit out of order here because it makes more sense in the long run. It's not really a value, it's an object that can act as a proxy to a property in an underlying value tree. To you as a developer, you don't need to know that. It feels like you're accessing a value even though this other stuff is happening underneath the hood. It's templated on a concrete type, which is how we can get type safety into this scenario. Any arbitrary data type can be supported. The JUCE value tree ecosystem includes a thing called a variant converter, which is a specialized template that you can declare for any data type that lets you figure out how you're going to serialize your complex data structure into something that can be stashed into a JUCE var. One of the reasons, like in object-oriented programming, we're taught that we have to keep our variables private because you want to make sure that anything that the class needs to guarantee as an invariant is not messed with by somebody reaching under the hood. I wanted to be able to make that a little more flexible, so there are callables that you can assign to any value that will let you do that type coercion and validation on the fly without users needing to know that they're doing that. It's just encoded directly in the same way that a get or set function might be in a standard C++ class. Any value can optionally have an onProperty change callable assigned to it, which lets you from anywhere in the app watch at a granular level of an individual variable anytime that value changes, which ends up being very cool and easy way to respond to changes in the app without anybody knowing that it's being watched or necessarily who's changing what it's watching. And one other cool thing that I snuck in because I wanted to play with some template things that I'd never done before, there are numeric arithmetic operators defined, but only for the numeric types. So that was kind of fun. The value object contains a reference to the object to which it is a child, which is how the magic happens. It just keeps asking its parent, the object, what's my current value in the value tree? It has an identifier specifying its name. Must have those things, which we don't need to go into too much detail because 18 minutes. The idea I keep coming back to is an idea that came from a language called Eiffel, which had a brief burst of interest about 25 years ago, but then everybody forgot about it. But basically the idea that Bertrand Meyer, who invented the language, was what he called the uniform access principle. Everything should be behind a dot. You shouldn't need to know if you're accessing a raw variable. You shouldn't need to know if it's calling a function. It should look the same to you as a user, which lets you build simple structures and grow complexity naturally without anybody downstream calling your code needing to know that the code has gotten more complex behind the scenes. So again, that dot access is my my goal there. This is pseudocode. I don't want to go into too much detail other than to say the way we implement it is by templating on the underlying data type, creating an operator equal so we can do set operations by passing it in any kind of type. If there is a validator function on set, we call it and possibly modify the value on its way in. If we need to do anything to convert it into that JUCE var format, we do it here. Set it in the underlying tree and return a reference to that value so we can keep chaining these things along. It really feels like working with just raw data. And getting a property value does basically the same thing. We create an operator T, which reaches back into the value tree, gets its current property from it. If it needs to be converted from that var into the raw data type, it does that. If there's an outbound validator, or we call that on the way out and get that back. Object is the parent that owns a bunch of things. It has a JUCE value tree. It is a JUCE value tree listener. It may have an undo manager. If you want to do undo, redo within your code, the raw JUCE API requires you to manage that manually. This just hides it underneath. It can have one or more value members. It can have 0 or more children. Undo, redo, and persistence is handled automatically for you. Exposes what is called NoSQL-ish database operations, which is a very cool way. The app that my team works on has to manage hundreds and hundreds of pieces of content. This lets us query that without needing to link in SQLite or some other database. We can do everything in ValueTrees internally. So to create one of these value members, all you have to do is create value, template it on the type that you want it to be, give it an identifier, point it to yourself, and initialize it. I hate macros, but it makes a lot of sense to have a macro to do this for you. So in practice, a lot of the Cello classes that I use are nothing but this with a list of however many values there are in that macro and no additional code. Everything else is provided for you automatically. When you're handed to create one of these objects, you either have to create the underlying value tree or you're given a value tree from another object. And the question is, are you creating it? Are you wrapping it? We need to know these things. If it doesn't exist, it will go through and initialize all of your values to their expected states. And there are a bunch of rules for this. We don't need to go into detail on this here. One thing that I did for this that I thought would be more interesting than it was building something like an XPath syntax. So given this very complex tree, to be able to instantiate an object specifying child relationships and grandchild relationships. In practice, it tends to not be too useful in my experience, but maybe other people have different experiences there. We receive a bunch of callbacks when things change. The most common one is on property change. So as things are used in the app, you're listening to a variable, you'll get called back every time that variable changes, but also anytime any of the child relationships change, which is lets you respond as your app changes dynamically. Again, we talked about this a little bit earlier, functional reactive programming. Being able to get and set from any point in the app, something that's visible every place else in the app is super useful. The nice thing about that is that everything is decoupled. You can add things on the fly without needing to recompile things too much. And where things live is not your problem. You just listen, and as the things change, you respond to it, and logic goes where it belongs rather than where it's convenient to place it. Oh, already, okay. So we're gonna slam through these. So the Cello query class just lets you do those NoSQL-ish queries and sorts and things on a database-like set of trees. Sync lets you thread sync between two threads. IPC client extends that to being able to keep value trees in sync across different processes. Let's skip this unless it's gonna, no, it isn't gonna go. I'm gonna skip all of these, quick talk on some case studies. Analytics had a product manager come and say, well into the app's lifestyle, we needed to add analytics at a very fine-grained resolution. Because of this, I was able to add one single file that was just listening, added the analytics without needing to touch any other code anywhere else in the system. What we thought was going to be very painful ended up being very simple. The MIDI comms, we use 2 separate threads for dealing with our devices over MIDI. This allows us to keep everything completely in sync without needing to worry about anything getting slammed by anything else. The content library, we talked about this a second ago, which uses the query operations to do database searches on contents. Don't need to talk about this for now. The real lesson is, should you use this? I don't care. The real lesson, I told you that story, so the story that I can tell you is, if you spend any time on the JUCE forums, there are a lot of people who like to complain about things that JUCE does not have. You, each and every one of us, has the ability to go in and say, why don't I have this? Why don't I build this myself? Build it for other people. Share what you make. Is Sudara here? I know Sudara Williams here. He has a wonderful Git repo called Awesome Juice. I'm done. Okay, thank you.